All right, let's take a look at problem 4 here, which is exercise 1216 from the text. And so we're told the data below is for VLE of a system of two unnamed components. And first we're asked to calculate the activity coefficients of the two components and plot them against x1. Your graph should be done on a computer and it should be annotated properly. Okay, so we're given pxy data here, so temperature must be constant. Okay, and so in A, first thing we're asked for is, given this data, calculate the activity coefficient of gamma 1 and gamma 2. Okay, let's do it. So the key would be is just to write down my modified Raoult's law expressions. Okay, so this is essentially our data reduction type of step. So y1p is equal to x1 gamma 1 p1 sat. Okay, so if I look, I should point out here, so if I'm thinking about a pxy, pure component limit, so limit that x1 is equal to y1 is equal to 0, okay, this, okay, would correspond to p2 sat. That would correspond to my limit of pure component 2. This would correspond to my limit of pure component limit of pure component 1, so that'd give me p1 sat. Okay, cool. So if I look at my phase coexistence criteria and solve for gamma 1 would be equal to y1 p divided by x1 times p1 sat. Okay, let me put parentheses right around that. So if I'm looking at, say, row 2, okay, I know x1, I know y1, I know p. Okay, I know x1, I know y1, I know p, and I know p1 sat. Okay, so I can go ahead in row 2 and calculate gamma 1. Okay, likewise, I can calculate gamma 2. Gamma 2 would be y2 p divided by x2 p2 sat. All right, where x2 is just 1 minus x1 and y2 is 1 minus y1. So it would be the same thing. I know, y2 and x2. I know p2 sat. I know p. So I can go ahead and I can solve for gamma 2. Cool. Okay, then we look at B. B asks, does a system exhibit positive or negative deviations from ideality? What do you think? Well, if we were to just plot our gammas, right, and so, you could either plot gamma or you could plot log gamma. So remember, the idea is that for modified Raoult's law, okay, well, for Raoult's law, okay, P bubs, my bubble line takes the form of x1, gamma 1, p1 sat. Ugh. Well, for modified Raoult's law, it takes the form of x1, gamma 1, p1 sat, plus x2, gamma 2, p2 sat. Okay, for an ideal solution described by Raoult's law, I have x1, p1 sat, plus x2, p2 sat. Okay, so positive deviations from Raoult's law. Okay, so I'm looking at positive. Okay, positive deviations from Raoult's law would correspond to when my actual bubble point pressure is greater than that of a corresponding ideal solution at the same composition. So I'd have gamma 1 and gamma 2 are going to be greater than 1. Right? So it's going to correspond to a gamma is greater than 1. Negative deviations would be when my actual bubble point pressure is less than that of the corresponding ideal solution. So when I have gammas less than 1. Or if you're dealing with logs, log gamma is greater than 1, log gamma is less than 1. Okay? Now it just asks for positive deviations from ideality. Okay, so the other way you could look at this is, remember that GE over RT, okay, is going to be equal to x1 log gamma 1, okay, because remember this is just G bar 1E over RT, plus x2 log gamma 2, okay? And for an ideal solution, okay, so in the ideal case, so for an ideal solution, GE over RT is just equal to 0. Okay, so if I have positive deviations from ideality, positive, I'm going to have So for positive deviations from ideality, GE over RT would be greater than 0. Negative would be GE over RT less than 0. Okay? And so GE over RT, all right, is x1 log gamma 1 plus x2 log gamma 2. So since I've calculated gamma 1 and gamma 2 as a function of x, I could go and I could calculate GE over RT as a function of x. Okay? And so that's exactly what I would do. So if I have, say this typed up in Excel, x1, y1, p, I would add another column for gamma 1 and gamma 2. Then you could add another column on top of that and get GE as a function of composition. And what I'm looking at then is an A. What I'd actually do is rather than just plot gamma 1 and gamma 2, and actually I'd plot log gamma 1 and log gamma 2 as a function of composition, I would add to that plot GE over RT. And I'm looking for is GE over RT positive or is GE over RT negative? Okay, if GE over RT is positive, then I have positive deviations from ideality. If it's negative, I have negative deviations from ideality, right? So I plot GE over RT versus composition, and I just look to see if it's positive or negative. Okay, cool. C, determine whether the system is best described by the Margules or Van Laar equation. So the text, when they talk about Margules, typically it's 2 suffix Margules, but who knows, could be 3 suffix. Actually, no, I take it back. Here I'm going to interpret it as 3 suffix Margules, the 2-parameter expression, because Van Laar also has 2 parameters. And so basically what I'm going to do here is, so I'm going to calculate GE over RT as a function of composition. Right? I'm going to do that because I'm going to need that in order to determine if I have positive or negative deviations from ideality. So I calculate GE over RT as a function of composition. I have that tabulated. Van Laar equation and Margules equation can just can be thought of as they're going to be 2-parameter analytic expressions for GE over RT as a function of composition. So basically what you're just going to have to do is you're going to have to fit Van Laar and Margules to my GE data and see, which one results in the best fit. All right, and so what I would probably do with Solver is if I have, say, x1, okay, and then I've calculated, say, GE over RT as a function of composition. Okay, so this would be, my actual. Okay. Then I could have, my model prediction. Okay, and so say this is Van Laar, and I've got some constant B12 and B21 saved over here, say in a cell in Excel. Okay, so I've got my actual data calculated. Okay, and actually I know the pure component limits at 0, so I probably would even exclude those. Okay, so I have those actual values. So I would have some, say guess of B1 and B2. I could use those to calculate GE over RT using my model at those intermediate compositions. And then what I want to do is minimize the sum of squared error, right? And so I want to minimize, so my objective function would be the sum of G over RT, okay, I don't know what you'd call it. This would be my ith value. So for, given x1 value for my ith row, actual minus GE over RT I model at squared, right? And so basically I'd want to minimize the square difference between my actual GE values and that of my model, right? I square it so that all of those differences are positive. So I don't have, some cancellation of signs, which doesn't actually pertain to the fit. So what I'd want to do here then, it should have been an eraser. So what I want to do here is you can have, if this are Excel, you could guess, values through two model parameters. With those two guesses, you can calculate your model GE over RT values, and then you're going to have, say, Excel use solver to adjust the value of B1 and B2 so that you minimize that sum of squared error. You do the same thing with Van Laar and Margules and just see which one gives you the smallest error. Essentially, which one gives you the smallest sum of squared errors, right? And that's how you would choose an excess Gibbs free energy model. It's just whatever one fits your data the best.